Good afternoon, everyone, and welcome to our webinar on Graph Neural Networks or GNN. I am Dhanashree Meshram, and today I'll be walking you through the end-to-end architectures of GNN, Graph Neural Network, from raw structured data to all the way in training, evaluations, and predicting the outcomes. So here, why graph? So the answer means here many real world systems like social networks, transportations, molecules, all these are naturally graph. Traditional machine learning treats item independently, but graph captures the relationship between them. So GNN, the advantage of using this GNN means it will learn the representation from nodes. Now, what is node? What is all these things? We will understand each and everything in our architecture diagram. So, we'll learn the representation of nodes and graph by aggregating the neighborhood information or neighbor information. So, it is powerful for linking the prediction, node classification, graph classifications, and so on and so forth. So what are the different applications here? So here we can use it for recommendation systems. We can use it for drug discovery, for fraud detections, for all these, like if there is some fraudulent transactions happening, for that we can use this pattern matching things. Likewise, we can use it for drug discovery, for analyzing the molecular graphs between the drugs, like how the two items, what is the relationship between whether they will have certain reactions or not. Likewise, we can use it for multiple purposes. Okay, so let's walk through to the architecture diagram. So here we are having the architecture diagram for this graph neural network. So here specifically we are focusing on a structured data. So we will begin with the raw structured data, which may be in the form of CSV, which may be stored in our databases, or which may have stored in our data warehouses. So we'll select from where to take that particular data and inject that data. Then we will select the data sources. Now, what is this data sources? So we'll choose the table or the data set that contains entities. Entities means whatever the features which they are having, like users, product, or multiple features will be there. And the relationship between these entities, like if the users are there, from this, what user purchase what product? Okay, so what is their relationship? Which when this person will buy this particular thing, the second person will also buy. So we can form a relationship between them. So here we will construct a graph. Construct the graph structure. So what is this in graph structure? We are having nodes and we are having the edges. So nodes will represent the entities. Entities means rows in the table. And edges in the features means it will have a relationship between, or what is the interaction or what is the relationship between the features. So that these two things we will find out from here. Okay, then after that we are having a graph construction. Graph construction from a relational tables, like we can have our join foreign keys to form an edges, or join the logs for interacting the interaction between the edges. Edges means the relationship between the two, and nodes means the entities. What are the different entities or what are the different rows in the tables? So here we will form a node features. Node features means what are the different node features, like what each individual features are there. Like for example, there can be numerical features, there can be a categorical features, there can be any other form like textual thing also there can be. So we can form a textual embeddings from there. Then we will have an edge features. If the edges carries the information, weight will like we will have some what is the weightage, what is the weightage between this and this being together. So we'll form the relationship between them by using the edge features. So here, after having the nodes and the relationship between them, which is an edges, we will have a GNN processing, graph neural network processing. Here we are having a initialization of nodes and edge features. Once the graph construction is there, once the graph construction has happened, we will create the initial feature vector for each node and edges. Initial features. And what is this? Repeat the k iteration. Repeat the k iteration means it is like a hyperparameter. Okay, we need to change this hyperparameter according to our requirement, like what it is giving, how it is giving. So k is nothing but the nodes, and we can change this hyperparameters according to our requirement. Then there is again second sentence, there is message passing iteration. Like here the message passing iterations will have two parts. First is an aggregate neighbor information, and second is an update node representation. So here in the aggregate neighbor information, we will have our nodes, complete nodes. What are the different nodes or what are the different features? Gather the feature vectors of all the adjacent nodes and we will form what? And the edges features if there are having some edge features between them or not, or relationship between them or not. We will have a common aggregation factor like summation, mean, maximum, or some mathematical operations or aggregation functions will be there. Then in the update node representation, what will be there in the updated node representation? So here we are having a combined aggregated message along with nodes own previous state. Okay, so repeat this k iteration. K iteration means we can have this depth of message passing continuously. Okay, what is we will change this k iteration according to this, and according to that the aggregate neighbor information and along with that the update node representation both will change. After doing this, we will have what? We will have our node level readouts and graph level readouts. After having this, we will have our node level readouts and graph level readouts. So here in the node level readouts, it will going to predict whether, for example, it might be classification problem, it can be a regression problem. Classification means if the output variable is categorical. If the output variable is numeric, we can have a regression problems. So for all this, we can have a node level and graph level readouts. So here in the graph level readouts, we will have our pool node. Pool node means all the node together, embedding into a single vector formation. Like summation of all the pooling, either we can have a summation, either we can have a mean pooling, either we can have an attention pooling, multiple we can have. Likewise, in the node level, we will have our final node embeddings. We will pass through the final node embeddings and we will classify whether what is actually there and what is the actual representation. Okay, so here after this, we are having our output prediction. So here, after reading the readouts, it will yield the predictions. So for some tasks, we monitor if the predictions or stabilizations, and we will adjust this k value accordingly. This k value is nothing but an hyperparameter. Okay, this is a message passing, which we are passing it. Okay, so this k value we are iterating, changing it continuously. Okay, and then changing this thing also and changing the output also. Likewise. So here after output predictions, what we will do, we will have our loss function. Loss function will compute the loss function. If the losses are more and the accuracies are less, we will go and back propagate. We can use our optimization techniques like early shopping. We can have multiple optimization techniques like add-in, stochastic gradient descent, RMS prop, multiple optimizations techniques we can use and update the weights here. Accordingly, we will have our validation and evaluation. Here, in the validation, we will monitor the performance on unseen nodes or unseen graphs. Okay, or a test data we can say. So here the matrix can be, if the output matrix here isn't categorical, for example, classification problem, we will have an accuracy score of either accuracy, F1 score, ROC, and if the output variable is numeric or a regression problem, we can use a root mean squared error, ME, R square, multiple things we can use. We can also apply early stopping to if the validation loss is not stopping. Okay, it's not getting improved. So we can apply a early stoppings also. Okay, so here when it comes to key hyperparameters over here, so we will have a number of layers, which is k. Okay, which is a hyperparameter over here. Then the embedding size, how much embedding size we are taking. Then the aggregation type, what is the aggregation type? And the next thing is learning rate. What learning rate we are going to take. So these are all the hyperparameters that we are going to take it here. Okay, so likewise, here we are having a raw data. The raw data, we are forming one graph. We are forming one graph with the help of nodes and edges. Nodes are nothing but the features and the edges means what is the relationship between them. Then we are having a GNN processing wherein we will initialize our node with respect to the edge features and then we can have our key iterations or k iterations. From this, we will have our aggregate neighbor information and update node representation. So continuously according to this k, according to this layers, this change is happening here also and in the node level along with the graph level readouts also. So accordingly, the output prediction is changing. Okay. So here, when the loss is lesser, what we will do? We will again go back propagate and by using the optimization techniques. We'll add some different optimization techniques we can add to increase the accuracy and reduce the losses. Okay. Here we can also add the early stopping stage. After this, we will have our validation and evaluations on unseen data. So that our model, it should not get overfitted, it should not get underfitted, it should be right fit. Okay, so this is what our graph neural network is. Okay, so let me walk through you guys through. See here, what we are doing means here we are having our PyTorch framework instead of uh, TensorFlow framework. Here we are having an easy framework, which is a PyTorch framework. We are using this PyTorch framework. We are initializing our model here. You can see we are having an in features, hidden features, output features, and number of layer here. This is a hyperparameter, which is k. Here we are taking as 2. According to our requirement, we can change it. Okay. So here we are passing it and we are having this thing. You can see number of nodes, we are having 100. Input features, we are having 16. Hidden features, we are having 32. And output features, we have 2. Means this is a like categorical column. That is why we are having 2 outputs or 2 features are here. So likewise, we are just running on. Here we are training this thing. You can see here we are having some optimization techniques. Like here we are using an Adam as an optimizer. Learning rate we are keeping as 0.01. We can change it to some other number also. Here the optimization technique, instead of Adam, we can apply SGD. We can apply RMS prop. Multiple. You can change this thing according to your requirement. Since this is an hyperparameter. Okay, you can change it and you can see the result, what the changes are happening. Okay, so likewise, we are running 20 epochs over here and you can see the output. By running 20 epochs, it is giving the output like this. Okay, you can see this is the losses for the first epoch, this is the accuracy. Like you can see, once the second epoch and third epoch it reached, you can see the accuracy is nearly 100%. And the losses are reducing. The losses are continuously reducing after running 20 epochs. Okay, so this is it, guys. So this is we understood about graph neural network. How, what is node, what is edges. We have understood about what is the relationship between them, how we are going to train this particular model. All these things we have understood in the today's lecture. Okay, so here as you can see, these are our contacts. Okay, you can contact us through LinkedIn. You can contact us through multiple sources. This is our mail ID. This is our contact detail. You can call us. We are having centers in Hyderabad, Bengaluru, Chennai, and we are having a franchisee centers in multiple locations like in Pune, in Bhilai we are having. Now in Noida we are having. So multiple locations are there according to your requirement. You can choose the location. You can enroll our classes through online sources also, like online sessions also you can take, or if you want an offline led sessions, so you can enroll for offline led sessions also. Thank you for joining, guys. We'll meet with a new topic on the next